And now let us see an example of formation of a compound from two elements. I'm taking the example of sodium combines with a chlorine, you will get sodium chloride, right? So when you balance, you will have two here to balance the chlorine, and when you balance the chlorine, you will have two sodium on the right side, so we have to put two here too. So sodium is in the elemental form, so we have to say the oxidation state is 0. Chlorine is also in the elemental form, so I have to say oxidation state is 0. Whereas this is a compound, so we have to have oxidation number or oxidation state for each species here. So sodium ion, so it is +1. Chlorine is in the 17th group, so -1. So you can see that. Why is it like that? Because sodium, how many electron in the valence shell? 1 electron. And chlorine, how many electron in the valence shell? It will have 7 electron in the valence shell. So when it forms a compound, it is transferring the electron to chlorine, and then sodium will form sodium ion and chlorine will form chloride ion. And chlorine will have how many electron around it? 8 electron around it, right? And sodium will not have any electron in the valence shell now. So here, since sodium is losing electron, the oxidation number changes from 0 to +1. That means oxidation number is increasing from 0 to +1. So we call it as oxidation. Okay, and the oxidation number for chlorine changes from 0 to -1. That means it is decreasing in oxidation number or reducing in oxidation number. So we call it as reduction. So who is oxidizing here? The oxidizing species is sodium, and reducing species is chlorine. So we have to always pick from the reactant side. Okay, reactant side, we will get both oxidizing species and reducing species. So we are calculating from reactant side and product side the oxidation number just to decide which species is oxidizing and which species is reducing. We will see more examples now. Right, so in this example, we can see magnesium combines with oxygen to form magnesium hydroxide and hydrogen gas. So magnesium is in the elemental form, so we will have the oxidation number 0 for that. And in H2O, oxygen we know -2 and hydrogen +1 for each hydrogen. And on the right side, magnesium is +2 and hydroxide ion together it is -1, and we have two hydroxide ion, so -2 and +2 will cancel each other and we will have 0 for this compound. And hydrogen is in the elemental form, it will have 0 oxidation number. So in which case the oxidation number is increasing and in which case the oxidation number is decreasing. We can see that for magnesium it is changing from 0 to +2. That means oxidation number is increasing, so that is oxidation, right? And for hydrogen we can see that +1 is changing to 0. That means it is oxidation number is reducing, so it is reduction. So that's how we can decide the oxidation reduction species. Okay, so we can say that the oxidizing species here is magnesium and the reducing species here is water. So this is oxidizing and it helps the reduction of water. So we can say that this is the agent for reduction. So we will call it as reducing agent, and the reducing agent is oxidizing and water is undergoing reduction, and it helps magnesium to get oxidized. So we can call it as oxidizing agent, opposite. So an oxidizing agent oxidizes another substance and is itself reduced. A reducing agent reduces another substance and is itself oxidized. One more example, let us see this one. Let us decide whether the reaction is a redox reaction or oxidation reduction reaction by looking at the oxidation numbers. So in HBr, we know hydrogen is +1, Br is -1. And in the case of calcium, we have +2 and hydroxide ion is -1. And on the right side, in the case of water, we can see hydrogen is +1, oxygen is -2, and calcium is +2 and Br is -1. So what's happening here? For hydrogen, is there any change? On this side, it is +1, and this side is also +1. For Br, it is -1. On this side, also -1. We are not looking for the total charge. We are just looking for the single element, single atom. So here, calcium is +2. Here also calcium +2. And is there any other change? Oxygen, if you are splitting this one, we can see that oxygen is -2 and this is +1. So oxygen is also not changing. So we can decide now that there is no change in oxidation number for any of the elements here. So we can say that this is not a redox reaction. Not a redox or oxidation reduction reaction. So that's the purpose of calculating the oxidation number.